Okay, so today's lesson 1 of COMP2084. It's January 2018. So we're just going to have one video stream for today. We didn't have a video for the first part of class. So we want to just have a look at, make this visible to you guys, a visual of kind of how the MVC pattern works. So again, this is not particular to the .NET environment. It could be, it could be a Ruby on Rails application, could be a Node.js, could be a Laravel PHP application, but they all basically follow the same pattern. So the idea here is that we get some kind of request from a client. That client is handed to a dispatcher. So that might look something like this. And one of the other nice things about using the MVC pattern in the web world is typically we get friendly URLs. So we might have something that looks like a URL that looks something like this. So if we have a URL, we got a request in that comes here. What would you expect to happen at this URL? It's a pretty descriptive URL. What do you think would happen on this page? Okay, and what kind of content would you expect based on this URL? What would that HTML page show us? Yeah, it would probably show us information about many students or one student. Probably one student, and which student would it be? Right, so typically the URL is really important in the MVC pattern. So here's the way this would work in an MVC pattern. So a user either clicks a link or types this address into the address bar. So they're making a request. So this will get handled by a web server. So here's the way this is going to get broken down. The web server is going to hand that request to a controller. And the controller is going to decide what to do. Now, in our application, we probably have a whole bunch of different controllers. So if our URL is this, what do you think the name of the controller that's going to handle this request is going to be? Yeah, it's probably, so here's how it would work. We're going to have a file with a C# extension in the controller subfolder called students plural. You'll notice there's an S here, controller. Right? So we may have courses controller, instructors controller, classrooms controller, etc. So the controller is going to take that request and it's got to decide what to do. Right? Our controller is our logic layer. It's kind of our traffic cop. So if we want to ultimately retrieve the data about student 1, 2, 3, what is the controller going to do next when it takes in this request? Or in fact, I guess just to modify this a bit, in MVC5, it'll actually look like, our URL will look like this. You got it. So our students controller is a details method. Pass in an integer. The logic layer, our controllers, they don't talk to the database directly. The models live in between. So basically, every table in our database has a corresponding controller as well as a model. So the models, those are basically just business classes. So those would be similar to the kinds of objects you created in your OO class, probably with Jared, right? You know how to make Java classes with getters and setters and public properties. So our .NET environment, our .NET MVC architecture, we're going to have similar classes, right? If we were building a system like Blackboard, we'd have a student object, or student class, an instructor class, course class, etc. So the controller talks to the correct model. The model will go into the database and perform the create, read, update, or delete operation we need. So in this case, we're doing a read operation. We're selecting student 123. So we pass in an ID, and it returns us back a student object. The model accepts in parameter. Now our controller has an object instantiated with all the information about student ID 123. First name, last name, email address, grades, etc. So now that lives in the logic layer. What do we need to do in order to actually render that information in the browser? How does it get from the logic layer to the UI? You got it. So the model gives that student to the controller. The controller then takes that, it loads an appropriate view, and it passes that object along with it. So now the controller will load views students. Views have this extension, CSHTML. So this is how that whole process works. So the model, this just fetches things, sends things to and from the database. You can almost think of this feature here, the model's almost like the server in the restaurant, right? They take requests, they go to the kitchen or the bar, they make those requests, they bring back whatever's been asked for. That's really what the model is doing. So the controller is kind of like the traffic cop. It directs everything. It looks at all the requests. It decides what models to interact with and what are we asking the model to do. Are we saving data, selecting data, updating, or deleting? And then it also determines what views are we sending back. Yeah, the controller is the middleman, right? But the controller doesn't reference the model or the views directly. It's abstracted. So this could be a web application, could be a mobile application. Right? But the controller and the model, it would actually be the same in both cases. It doesn't care what the UI, what the view is. We could change the UI. We could build this. And then we could create a web front end and a desktop front end and a mobile front end, 3 different sets of views, but all using the same set of controllers and models. Or we could chop the view layer out altogether. We're going to do this at the end of the semester, and we could build a REST API. So we'll use .NET Core for doing that. So we can accept JSON requests in and send JSON data out. But there is no front end. We're just sending it to some other developer and they can build their own front end with whatever they want. So this is what all of our, this is how all of our patterns are going to be handled. So in this case, maybe it's a read request. If it's a request here, rather than just taking an ID, right? It's going to accept the whole object with all the properties the user's modified. And we want to push that back to the database to update student 123 with new information. But we're going to do this same structure over and over again. Sometimes I show this, and I'm going to show it right now. It's another really short video you can look at on your own. I think it's less than 10 minutes. I won't stream a video within a video. About 5 minutes long from lynda.com. It's a pretty good overview of what the pattern looks like. Okay, so that link is here for you just as a resource. Okay, so let's fire up Visual Studio and start to play around with this a little bit. Let's see what we get here. So open up Visual Studio. You'll probably get this splash screen. Excuse me. So we're going to create a new project. So you create a new project. Make sure you may not, it always defaults to whatever the last type of project you created is. So yours will probably default to a Windows project. So you need to make sure under Visual C#, you click on Web. If you don't see Web templates, that means you need to run the installer again and check off those options that I went through in the beginning of class. So we've got two options. We've got .NET Core, which we're not going to use, or this one that says .NET Framework. That's our MVC5 template. So that's what we're going to use for most of the time in this course. So we'll create a project for today. We'll probably create one more next week, and then we're going to keep adding on to that project each week. So one thing we're going to discuss either later today or the start of class next week is what are we going to build in class. Last semester, we built an online music store. I've been doing that for a while. I think what we're going to do this time is we'll take a poll. I'll have you guys make some suggestions, and we'll kind of have a vote on what we're going to build together. We won't build a music store. We'll build something else, some other kind of online store. So again, each week, rather than building something new, we're just going to keep evolving the project that we set up, I think, this week or next. Okay? So that's also why it's important that A, you're in class, and if you're not, you catch up in the week between Wednesdays, because we're just going to keep building on to what we're doing. We're not going to build 14 separate applications. We'll build one and we'll grow it. So pick .NET Web Application, save it wherever you like. I'll just call it 2084. Lesson 1. You can initialize Git now, or we can do it later. Doesn't really matter. But just make sure you're picking ASP.NET Web Application, not .NET Core. Save it wherever you like. So then we get to this screen, asking us what kind of application do we want to build. So we want to pick MVC. Web Forms is really old technology. That was kind of the first iteration of .NET that came out in 2002. So for years, I actually still have some legacy apps that use Web Forms. Microsoft's they moved away from this, and now they don't really support it at all anymore. Okay? We could build a single page application or an API. We'll build a web API later on. But if we pick MVC, it checks this box. We don't need Docker. That's like cloud containers. They're kind of cool, but it's sort of beyond the scope of our course. So don't check off Docker. Next week, we'll add unit tests, but we won't just for this week. We'll just leave that off. We'll get into unit testing in March. I know you've already done unit testing with Java. We're going to look at how to do it with .NET later on. The other option here is by default, it says no authentication, meaning everything we make is public. We'll change that. If you click on change, we get these three different options. So we can either, right now we have no authentication. We can store profiles in an SQL Server database. We can use existing Exchange accounts. So like on an intranet at the college, if everybody has an authenticated Microsoft account, we can use that. Or we can use local network authentication if we were building an intranet. So most of the time for a web application, we're going to want this one. Right? We're going to want to store credentials, authenticated credentials, hashed, salted, etc. And that we're going to ask. I'm going to pick on you a lot when we get to security, because I know you were doing application security at BMO. Okay, we will do authentication and security. Maybe our most important topic. I think I'm not sure if we'll do that week 6 before the midterm or week 8 after the midterm. We'll pick individual user accounts and we'll let Visual Studio chug away and do its thing. Microsoft Azure for hosting, but we won't do it yet. You do get some Azure credits, but it only gives you so much time on the server. It's time and resource based. And last semester, some students ran out of Azure credits before the semester was over. So we'll try to manage those credits a little more judiciously this semester. So we won't be posting stuff on Azure until we really need to. And then if you post anything there for grades, as soon as I mark it, you want to take it down. Because it's time-based. The longer things are deployed online, the faster that eats up your hosting credits. Yeah, we'll talk about it another time. So here's what we get. Here's our structure. So let's kind of poke around and see what's in here. So this will be quite different from what you're used to seeing with your Windows solutions, right? Different folders, different settings. So we'll kind of poke around what's here. It gives us a whole pile of reference libraries. This is actually about 90 megs worth of reference libraries. Okay. So by choosing that individual user accounts, it's added a whole bunch of packages called ASP.NET Identity. So this is all around managing user authentication and authorization. It also even pulls in some hooks for OAuth. So we want to enable things like Google, Microsoft, Facebook sign in, which we will do later on. We'll let people either create an account or sign in, say, with Google. We'll add that later on, okay? So the support libraries, they're already here. If we had chosen no authentication, these packages wouldn't be here, these packages wouldn't be here. So our application footprint would be smaller. We've got Entity Framework. This is Microsoft's data access library that's used to connect our application to our database. Kind of the equivalent of the PDO library you would have used in Jess's class. We've got some startup files here. We won't mess around with these too much, a little bit later on. And we've got this one here. Here in the root.config, this sets up the URL mapping. So this file sets up what happens at each URL. How are they to be interpreted? So the default structure is this will be a controller name. This will be a method within the controller. This will be any parameter that that method requires. And you can see that set up right here. Controller, action. Microsoft uses the term action rather than method, means the same thing. And then any optional parameters. And it says the default is the home controller and the default action is called index. So that'll be in effect our site homepage. So we can override these. If we don't like Microsoft's URL pattern, we want to use a different pattern, we can override the settings in this root configuration. We're not going to, but if we wanted to, here's where we could change it. Here's some things for setting up cookies to manage authentication, whether we want to enable two-factor authentication. And here later on, it already has the code commented for enabling OAuth authentication through providers like Facebook, Microsoft, and Google.
Can we like specify post or that?
Rather than specifying it in the route, that's handled through the controller. Okay, so that's a really good question. So let's think about this, right? So about this URL. Okay, at this URL, what HTTP method would we need at this one? Post or get? Okay, well, what would happen at this URL?
We send data to this controller and it creates rows inside the data.
Yep, absolutely true, right? We would get data from the view and post it. Controller would save it to the database. So we would definitely need a post. I would suggest we also need a get at this exact same URL. Why would we also need a get? And what would be the difference between those two versions? All right. Okay, could be for an API, yes. Well, post. Okay, so if we ran post at this, you're right, that would submit data and save. But what would get do? And which one would run first, get or post? Why would we also need a get method for action at this exact same URL? Even before that, what would we have to give to a user before we could do a post? In the UI, in the view, what would we have to give to them if we wanted them to post data? No, because that would come after. The user ID would come after they posted a new record. What do we have to give to the users if we want to get data from them? Right. So if we have a get request at students/create, we need to display a view that shows a blank student form. When they click the submit button, it then calls the same URL, but this time it runs a post request. So we're actually going to have two methods called create in our students controller. One that runs a get and displays a form, and a second method that runs a post that then submits that form. That would do the validation, check if things already existed, and then get the new ID. So we'll have two. So rather than those things being set up at the application level, that would be within each controller. Every form, and it would be the same if we had edit. We'd have a get method that would display the form with the data populated, pre-populated with the current data. Then we'd have a post that would process an update. We've got a content folder here. These are for static assets, front-end assets, basically CSS media files. So images, photo, video, those are going to go in content. And notice it also gives us Bootstrap and gives us a default style sheet where we can write our own custom styles. If you don't want to use Bootstrap, that's fine. You can get rid of it. You want to add a Bootstrap theme file, which we might do, fine, add it in here. Again, this is one of the things Microsoft said, well, developers aren't going to create all their CSS from scratch. They're going to use a framework. They're probably going to use Bootstrap. Let's just put it in here. By default, you don't want it, you can get rid of it. So we have three controllers here by default. The account controller, if we open it up and look at the methods, we have methods for processing external logins, confirming an email address, forget password, register, login, log off, enable two-factor authentication. All this stuff is already pre-built for us because we changed no authentication to individual user account. So we can get rid of or modify any of this code, but we don't have to start from scratch, which is great. We have a home controller with three methods. So this is what a typical controller will look like. Our controller inherits from the base controller class. We have three actions here called index, about, and contact. Interesting. Okay, if that happens, let's try to compile your code. So if you click on the build menu and choose build solution, this will be the first of about 8,000 times you're going to click build solution this semester. See if what happens. So just let me know when it's done, and don't worry, you won't be interrupting. So we've got 3 methods here called index, about, and contact. Each one returns a view. But notice the return type. This is a class you guys won't have worked with before. Each method returns an action result, which is part of the system.web.mvc namespace. So action results, most of the time, are views. Most of the time, our controller methods are going to return a view. We want to load a web page. Yep, same thing. Okay, I'll have to come and look at the errors. But it's probably one problem that will fix them all. So don't panic. So most of the time when we call a method in a web application, we want to load a page. What else might we do occasionally? So a view is a child class of action result. So typically we're going to return views, but what else, what other kind of response might we want to return instead of a view?
Maybe just a variable for second method.
Okay, yeah, one method might just return a variable. Anything else we might return? Well, not an individual control, but not a bad guess at all. What typically happens, we had talked about posting a form. If you get a form online and we fill it out and post it, what typically happens in the browser after we submit and save successfully? What does the application usually do? Sorry? Yeah, it could do validation. And where do you often get taken after you create new data? Yeah, often we get taken to a different page. So one of the other types of action results is a redirection. So we go, instead of just loading a page, we might call another method, and that method loads the page. So for example, we don't want to load the create view again after we post. We want to then maybe call the index method. We want to redirect the index method that would load the home page or a different page. So most of the time we're loading views. We could be returning redirects. We could also be returning error codes, like 404 errors, for example, or 500, 400 bad requests. So we can return HTTP status codes. Or we could return JSON data or XML data if we were building an API. Okay, so we'll do that later on. So most of the time we're returning views. And we'll come back, we'll talk about this little view bag object later. So there are controllers. Got a folder for fonts if we want to download and install custom fonts. We have a models folder, so this is where we'll create all our business objects. So one of the awesome things about Visual Studio Entity Framework is you don't have to both create a database and then create all of the business classes that map to the tables. You only have to do one of those two things. So if we build an existing database and connect our application to it, Visual Studio has an option to automatically generate all of the business classes from our database. So if we have 30 tables in the database, it will create 30 business objects, each one that's mapped to a table with all the validation rules and properties. Or we can go the other way. If we have no database, we could actually create all the business classes here in the models folder and then reverse engineer the database. Say, now go build those 30 tables from the 30 business models we have. So we don't have to do both. Again, Microsoft's trying to automate that process to save us time. So what we'll probably do next week or the week after, once we decide what we're going to build, I'll create the database, and then we'll generate the business objects from the database. We've got scripts. So again, they've brought in latest jQuery and Modernizer. If we want to write our own custom JavaScript, we just throw it in on the front end, just throw it in the scripts folder. Here's our UI. You'll notice a couple things about the UI. There are subfolders in here. So each section, each controller, we have a home controller, we have home subfolder. And notice our controller, we've got 3 methods: index, about, contact. And we have 3 views with the same names. And these all have CS HTML extensions. We also have a shared folder. We're going to work with this file a lot. So they actually give us a template file that will have Bootstrap and jQuery already hooked into it. It'll have a responsive navigation bar and a footer. So this is what it looks like. So this allows us to create a template or a series of templates, and then each view we create can inherit one of these templates. So we'll automatically get the layout and design from that template. Again, they're saving us time and work doing all this stuff. So we've got our CSS already linked. We've got code for scaling to multiple devices. We have a Bootstrap nav bar with links to our index, about, and contact views. This render body, this is where the individual page content is injected. All of the navigation up above, and then we've got a footer down at the bottom. So we can customize this, we can add to it, we can modify it, we can get rid of it. But we'll be making lots of changes in this layout file. On your final exam, there's 1 mark for putting your name and student number in the footer of your layout file. That's the easiest mark I could possibly give you. This also allows us to create multiple templates. Maybe we have different parts of our site, like we have a public site, and then we have an admin dashboard. But we want to use different layouts, different navigation bar, different CSS. We can create a public layout and a dashboard layout. Pages from the dashboard, use that layout. Pages on the public site, use the public layout. So we can create templates, modify our site layout and design really easily. Under account, we have about a dozen views all around authentication and authorization. So we actually have a built-in register form, login form, forget password form. All these things are already here. Again, we can modify them, get rid of them as you see fit. It is saving us time. Now, at one point, we'll launch this in a minute. Somebody always says, this is awesome. Like it gives me so much stuff. Why didn't you give us this last semester in PHP when we had to do everything manually ourselves? Right? We want to teach you how to do this stuff first so you know what you're doing. And now we'll put the tool in your hand that will automate it. If we just gave you the automated tools from the beginning, they would do work for you, but you wouldn't really understand what those tools were doing. So we make you do it manually first until you learn. The other file here that's important is our web.config. So this is an XML document with all of our application-wide configuration. So probably the most important section here is here. So our database connection strings are global. They go in this file. We put our credential here. So if we change the database, we only have to change it in one place. It's global within the application. It also sets up, so any configuration, so for example, we want to set up global error handling, we set it up here. This also allows us to define global variables and constants. So things like maybe we want to define properties of our mail server, so we can send email from various points in the application. So we need a mail server address, a port, a username and password that's valid on that server. Those credentials with web.config. If we want to set up things like API keys, which we'll do later, for our Google login, we don't hard code the keys into our C#, they go in the configuration file. It also lists some of the references and resources. So anything that's kind of managed globally in the application is through web.config. So that's kind of the basic tour. If I go and look at this project in Windows, so that default template, when I picked with user account, it's 115 megs we got. So it's not small. Had we chosen no authentication, it would have been smaller, because a good chunk of that 115 megs are all of the support libraries and all the views and code around authentication and authorization. One of the other great things about developing with Visual Studio is Visual Studio has its own built-in local web server. Unlike with PHP, where you either had to deploy your pages to a production server with FileZilla, which is a pain when we're developing, or you had to install a local server like WAMP or XAMPP that's baked right into Visual Studio. It has a local web server called IIS Express. So we can actually launch the server and see what all this stuff looks like. What did we get with our 115 megs worth of starter template? So if you go to the debug menu, now there's two options here. There's two ways to start your app. You can pick start debugging, but I don't recommend it. Start debugging will load the app, will load the site in the browser. The problem is when the debugger is active, it's just like when you're doing desktop development in Visual Studio. You can't make changes while the debugger is running, right? You have to press stop, make your changes, and press start again. But with ASP.NET, if you pick start without debugging, this compiles the site, launches the web server, but our code's not locked. So you can continue to make changes without having to stop and restart the app every time. So most of the time, I'm going to pick this one. There's one other thing I want to show you. One other folder we don't see. And this is critical, and I will definitely ask you a question about this on next week's review quiz in the midterm. The bin folder. We don't see it in Visual Studio. Notice it's not here, but it is here on disk. The bin folder, we said our ASP.NET applications are compiled, right? So we have all those CS files, the controllers and models. They all get compiled into a DLL that has the same name as our project. And the DLL lives here in the bin folder. So you'll notice, so my project right now is called COMP2084 Lesson 1. Right now, there is no DLL called COMP2084 Lesson 1. Right? I have never compiled my code yet. So if I build my solution, tells me it compiled successfully into the bin folder, COMP2084 Lesson 1. So here's my DLL now. Not very big, it's only 61 kilobytes. Nice and tiny. So this contains all the server-side code. So there's three huge benefits to having our code compiled. So we talked about performance. What would be the other benefits to having all our server-side code compiled into that DLL file? It's more secure, right? What about from an intellectual property point of view? Why is having our code compiled into the DLL better for us? Right. One of the great things about building sites in .NET is who maintains ownership of the source code. Right, you do, as we have it as the developer. Because if I want to deploy this site to a web server, here's all our C# files, our controllers. We don't actually have to put any C# on the server. All we have to put on the server are the views, the JavaScript, the CSS, and the DLL. So the actual source code never goes on the web server. So if the server gets hacked, we're putting on our client server, they don't have all the source code, we do. So if they want to change it, who do they have to pay to make changes? Us. So if I show you on a web server where we've got a .NET application, here's the bin with the DLLs. But there's no C# code on the server. I keep a backup copy on GitHub. I keep a copy on my computer, nowhere else. So I've got the source code. So I've been able to compile my project. So now we want to launch it in the browser. So click on debug, start without debugging. It will build it. So it will run on localhost, and every Visual Studio solution, it just randomly assigns a port. If you want to manually set the port for each project, you can. You can just go to the project settings and say, no, I want this to run on port 500. No problem. So here's what our 115 megs gives us. You get a home page with a header, footer, 3 links in our nav bar that call our about method, contact method, and load our sample views. It's mobile responsive. I can. Let's see. Right, so here I am. Different device, right? We get our little drop-down menu. We have a working registration page that will validate for strong passwords. For example, like this. Tell me, password's no good. The working login screen. So this is what it gives us right out of the box. That's what we got with our 115 megs. Good question. It doesn't, yes and no. You'll notice there is a database connection string here already, which is the data directory. So that's our app data. It will create a Microsoft data file with the name of our project and then the current timestamp. So it will actually create that file on its own. But we're not going to work with that. We want to actually create our databases ourselves using SQL Server. So we'll do that next week or the week after. And I'm going to show you, first of all, how to set it up locally. For the example we build in class, probably easier to just work with a local database. It's faster and it won't use any resources on Azure. But for your assignments, you're going to need to set up your databases and deploy them to the cloud on Azure. So I'll show you how to do that as well. Okay? So we'll learn both ways. But yes, it will actually work. If you fill out the registration form, it will actually save to that data file. So here's our working little application. Super easy to customize. So we could use that template and turn it into something like, let's see. So here's one I built not long ago. I used the framework. So I built that, used that exact same template to create something quick and easy. And I use the Visual Studio tools to go ahead and give me the ability to do, create, read, update, and delete really quickly. Working on a simple database. The login, log off is all working. And I just kind of use the tools. So I took the template that Visual Studio gave me and I just modified it, modified the CSS a little bit. It's mobile responsive, etc. So let's look at how these work. Right? Notice when I click the About link, we're going to kind of think about the pattern, see it in action. Right? When I click About, it takes me to home/about. So what's actually happening here? So let's go to our layout file because this has our navigation. So I've got a link here So you'll notice a couple things about the syntax. It's mostly like 90% standard HTML. But there's some things you've never seen before. What character in particular would be new for you in a web page that you haven't seen before? We see over and over again. Yeah, it's that yellow @ symbol. So this is the .NET MVC equivalent of those clunky PHP opening and closing tags. Right? So wherever you see the @ symbol, that means this is server-side code. Okay? But much easier, it's one character to type, and notice there's no closing tag, which is nice. And Visual Studio highlights that in yellow to point out this is not standard HTML, this is server-side code. So wherever you see this @ symbol in a view, that means it's server-side code. So this syntax that Microsoft created for their views, it has a name. It's called the Razor syntax. So this is their templating engine for views. So we see this Razor syntax everywhere we've got dynamic content. There's one other thing in particular. So notice here's our nav bar. Right? So this renders as plain old HTML. Right? This looks like standard links. Right? So we just get, I know it's a little hard to see, standard LI and A tags. But our code actually says HTML action link. Anybody want to hazard a guess? What is that action link method? You got it. So this is a server-side method that will generate a standard HTML link. So I could do this. I could still just type the code like this. Right? At runtime, lines 24 and 25 are going to be exactly the same. So why do you suppose in the template, and we're most of the time going to use this version, what would be the reasons to use that action link method as opposed to just using a static standard HTML link? They do the same thing. Both are correct. What would be the reason to use this version instead?
We don't have to, like, there's a default for the controller UI.
Okay, true. That would be great if it was, that would be an awesome idea. It doesn't actually do that, although you should take that idea to Microsoft, because the views are not actually compiled, right? It's only the file, only the models and controllers that have the C# extended, but that would be awesome if it did that. Which is a little more explicit about the fact we're using the MVC pattern, line 24 or 25. Yeah, so in 24, we're just calling a link. We're just linking from one page to another. In 25, what the action link parameters are, if we look, so the first value here is what does the link say? So the link has the word home. Second parameter, what is the name of the action this link calls? Calls our index method. In which controller? In the home controller. Because we may have a whole bunch of controllers, probably every one of them is going to have an index method, right? The home page for that section of the site, be indexed. So we're just being a little more intentional that we're not simply linking from one page to another, we're actually calling a method or an action in an MVC controller. So they're equivalent. It's not wrong to use this, but most of the time we're going to use that action link syntax instead when we're creating links in our views. So when we click About in our browser, we get this page. We get a title and we get this content. How does that happen? So in our home controller, we've got a method called about. It returns a view. So it's actually returning this view. How does it know? So here's our view. Use this area to provide additional information, right? So this is the page that's being loaded. But how does it know? We've got 3 different views in home. How does the server know which view to load? Right, the name of the action by default always loads a view with the exact same name. Right? Our action is called about, our view is called about. So if I do this, what happens if let's say I rename my view? And now I'll click my link again. So in this case, it's trying all of those. These extensions are old. These are web forms extensions. It looks first in the home folder, then it looks in shared. Can't find it. It tries all of these files. Now, so I would say 99% of the time, our action names will match the names of the views because it's just easier that way. If we really want to have a different name for the view and the method, we could. But then in my return statement, right, I've got to specify. Now it will load, my about method will load a view called about-us. So we'll try that. Click my link. Same error. How come? I'll give you a hint. Our code is not wrong. I did. Visual Studio is also really good for that because when you make a change, I did refresh it actually. It will show you a star whenever your file's you have unsaved changes. I did save it. I don't really need to refresh because I didn't change this page. So still I'm getting this. The code's actually correct, yet it's not working. How come? Code is fine. I am. Cornell, I'm coming back to your point about the views, right? What did you say about the action links? Right. So have I changed a view, a model, or a controller? What was the last change I made? You can see green's highlighting it, the little green indicator. Did I change front end code or back end code? Yeah, I changed the back end code. How do you know it's back end? Well, because the file is a C# extension. What happens every time you change your C# code in order for that code to be active? Close. I have to do, Giselle, what I asked you to do to fix your errors. You have to recompile. Right? If the views you can change and they'll just be refreshed. You change anything in the models or controllers, you've got to build the solution. Right? My DLL doesn't have my new code until I build. So I can just refresh it now. Every time you build, there's a lag, right? It's got to regenerate cache. Now it works. So we are all going to do this. I will do this every single week. Make a change and then wonder why it didn't work. And some bright person will say, you forgot to build your solution. That's why the change isn't up to date. So just making a change, I'll put this back. So just making a change here, I can save the file, change the message, but it's still going to say your instead of my. Right? If we look at my file on disk, I modified the controller, my home controller, at 134. Making that a change now that it's 135. So I've changed my controller at 135, but my DLL is still timestamped at 134. So that change will not take effect in my browser until I build. This is still saying your, it's not saying this is the. Once I build, now my DLL is updated. We know it's recompiled because it gets the lag on the first request after a compile. And now this is going to change. So we've always got to build when we're changing C# or adding new C# files. So if you add a new model, new controller, those files won't load until you build. Can't invoke them. Okay, we're going to do one more quick thing and we'll get out of here. Actually, and I will give you your lab. So let's make one more method and one new view. So let's add a link. We'll add a link, new link to our nav bar. And so we've got a home, about, and contact. What else? What's another link we can put in our navigation bar? A common link we might see on a website. I'm going to make one more dummy page. Okay, sure. We'll make a pricing method that returns an action result. And if we just want it to load a view called pricing, we only need one line of code. What do I need here? We just need it to return view. Now we'll create a simple pricing view, and then we'll add a link to the nav bar so we can click the link and get our new pricing page. So I'll just come down here. We can do it one of two ways. I can either right-click Views and Home and choose Add View, or there's a bit of a shortcut. I can right-click my method name and just choose Add View. So by default, the name of the view will match the name of my method. We'll just say it's empty, but you can see all the templates for doing create, read, update, and delete. So it's going to be empty. And then it says, do you want a layout page? Do we want a layout or do we want an empty page? Yeah, we want to use the existing layout template we have. So if I click here and go to Views, Shared, we can pick our pre-built layout template. So our pricing page gets the same header, footer, CSS as the rest of the site. So that's in Views, Shared, _ layout. So it gives us, we'll talk about ViewBag later or next week. It defines where the template is, gives us a heading. Just put some static content on. So now we should be able in our browser to try and load localhost /home/pricing. Try it on your machine, see what happens. What do you get when you try going to /pricing? .NET URLs are also not case sensitive because Windows is not case sensitive. So unlike in PHP where you're casing matters on an Apache server, if it's running on Linux, it is, doesn't matter here. So I could write this in all caps, all lowercase, Pascal case doesn't matter. So why do we get a 404? Because we created a new method in the controller and I didn't build. So that method is not part of my DLL yet. And the server's running the DLL, not running the source code. So if I go back and build and refresh, we'll get our minute of the few seconds of delay. So adding a new web page is that process. Create the method, generate the view with the same method. Now, we also want to add it to our navbar. So which file will we modify and what will we need to do in that file? Okay, we're going to change the layout file and then I'll let somebody else, or what are we going to do in that layout file? Yeah, we're going to add one more action link. We'll go back to layout. We're going to use HTML, the HTML library, and the action link method. So our first parameter is what does the text say on the link? The pricing. What is the name of the action this link will call? In which controller? Now remember, the views are not compiled, so there's no need to do a build here. We can just do a refresh in the browser. Our pricing link should be visible. So now we got our link. So building out your navigation and quickly generating at least your empty views is really fast. If we were building a static site, we'd basically be done the setup. You could just start doing the CSS and populating the content. So you can see how quickly we can set things up using this engine really fast. All we need to do is basically the design work and content population if this was going to be static. Now, it's not really designed for that. It's designed for doing more complicated things. But if you ever had to get a, somebody needs a site done really fast, you just need something up. And people will say this to you, I need a website, I don't have any money to pay for development. I just need like a one-page site for now. And I'll give you a few bucks to get it up. Well, here you go. You could probably do this in an hour and have somebody's site up and running super fast. Okay. So the last thing I'm going to do, I'm going to show you your lab, and I'm going to put this file up on GitHub because the whole lab is create an MVC project and put it on GitHub. That's all you have to do. So I'm going to do everything you need to do for the lab. So your lab, sorry, the requirements. So it's in the assignments tab. Here's what I want you to do. You're going to make a new project, new web application, not using .NET Core, using .NET Framework. Call it Lab 1. You can just accept all the defaults. So no unit tests and no authentication, because we don't need all the stuff for authentication. It's too big. You don't need it. You can either check the box that says create Git repository when you're doing it. If you don't, you'll need a copy of the Visual Studio Git ignore file, because we don't want those 90 megabytes of support libraries in our Git repository. So there's a template for Visual Studio. There's a template Git ignore file that ignores most of that stuff. Okay, so I'll show you where to get it and how to include it. Then on GitHub, you'll make a new repository called COMP2084 Lab 1. Push your solution and put the link on Blackboard. Here's my repository. I can create a template project with no changes and I can put it on GitHub for 2.5% of your final mark. This should take like 5 minutes to do. You have until Monday at 5 o'clock. It's lots of time to do. 2.5 easy percent. So make sure you do the lab. You have a friend who didn't come to class today, tell them to do the lab for their 2.5%. Do on Monday. Okay. By the way, GitHub, for those of you who didn't see, GitHub also just announced today that they are now making private repositories free for everybody. You will no longer get prompted to pay. You don't need the student account or anything like that. Microsoft just announced this today. This repository doesn't need to be private because everyone's projects are going to be identical. In subsequent assignments, then you will need to make them private and invite me as a collaborator so I can see your work. So I'm going to take today's lesson and put it on GitHub. Now, there's lots of different ways you can get your stuff on GitHub. If you're used to using the GitHub desktop tool, you can use that. Visual Studio has this tool called Team Explorer, where you can connect to a remote repository and push your changes this way. Personally, I like using the command line because I have the greatest degree of control. So I'm going to walk through using the command line with this. So the first thing I need, because I didn't check off create Git repository when I created the project, I don't actually have a git ignore file. So if I put this on GitHub, it's going to include these 98 megs of packages, which I don't want. I never want to see these in your repository. So the first thing I need to do is go and grab the Visual Studio git ignore file. I've put a copy on Blackboard for you. I'm going to go to weekly learning and tools and resources. Here is the git ignore file. I'm actually just going to open it up. You can't actually download it. Well, actually, here's the easiest way to do it. If you open it with Notepad, you can save it with this name. The file name is .gitignore. If you call it anything else, it won't work. So just open it with Notepad. And then I'm just going to click File and save it into my project directory. So here's my lesson one. So in here, so you see three folders, .vs, which is just some under the hood Visual Studio plumbing. Here's our web project, and these are our support libraries. One thing you need to change, if I hit save here, it's going to call the file .gitignore.txt, and then it isn't going to work. So you've got to change the type to all files. So the actual file on disk is called .gitignore, not .gitignore.txt. So now I'll save it. So my file is called .gitignore. Again, there's no txt extension. So this is a really big ignore file, and so it ignores all of these things, and in here it ignores the packages. Somewhere in here we don't want the packages, Azure published settings, et cetera, et cetera. So now I'm going to open a command prompt in this directory. So I'm just going to copy. And notice here, here's one of the other gotchas. There's two folders with the same name. Here's my top level folder. This is my web project folder. We don't want to run Git in the web project. It needs to be up at the solution level. How do I know where the solution is? It's got this .sln file. That's our Visual Studio solution. So we need to run Git from here, because later on we're going to have multiple projects in our solution. The web project and a unit testing project. So I'm going to grab my directory. If you missed this, I am recording this, so you can watch it in the video. I'm going to open up command prompt here. I need to run 5 commands. I need to initialize Git, add all my files, make a commit or a snapshot of the project, connect it to a remote repository, and then push my files. All the commands you need, they're right here. So first I'll do git init to initialize Git. I only have to do that once. I'll add all my files with git space add space dot. And all the commands are right here. make a commit with a message of lesson 1. I'll make a separate repository just for this week. After that, all the stuff I do in class, it'll all be in the same repository for whatever site we decide we're building next. So now I've got a local snapshot of what the project looks like now. So the last 2 steps are go to GitHub and create a remote repository, connect the remote repository with my local folder, and then push the files. So I'll just go to GitHub. I'll make a new repository. I'm not going to worry about a README file. We'll deal with those later. So I'll create the repository on GitHub. Now I can basically just copy and paste those 2 lines into my command prompt. This line will connect my local repository to my GitHub repository. The last line just uploads my files. So I'll just copy those. Click, hit enter. It'll push my files. It says it's set up, and if I refresh, there's our project. Notice the packages aren't here. It says I made 1 commit, which is time-stamped, which is why you'll never change your repositories after your assignments are due, because I can see when you do this. So there you go. That's all you need to do for the lab. Make a new project. You don't have to make any changes at all. Just make a standard template, create a Git repository, push it. You can use the command line if you want. If you like the GitHub desktop tool, you can use that. Or you can even use Team Explorer. And you can push changes here. So if I make changes, you can actually commit and push right through the Team Explorer and Visual Studio. I don't care how you get it on GitHub. Just make sure you have the correct git ignore file so that the packages, the 98 megs, don't wind up on the server as well. So this is like a 5-minute lab. Okay? So just submit the link to your repository. And as I said, I would highly encourage you to put a picture of yourself on your GitHub, unless you want me to ask you what your name is a whole bunch of times. Okay, so I'm going to stop the stream. Everything we've done today is on YouTube. It's on GitHub. I'll see you guys next week. Have a good week. We will have a quiz at the start of class, so make sure you're here for 11 o'clock next week.